Hey, my name is Mine Tokuş. I'm a product manager in Azure Data Team in Microsoft. And today I will talk about SQL Server on Azure Virtual Machines. Who are experienced with SQL Server on premises? Everybody, great. Who is using SQL Server on Azure? Quite a lot, so this is a great audience for me. So many of you today are running applications that require high availability, that has no tolerance to downtime, requires enterprise-grade disaster recovery techniques, and has no tolerance to data loss, and looking for mission-critical performance and security. So for such applications, enterprise-grade mission-critical applications, within all these offers platforms that you can use for SQL Server, cloud offers significant economical advantages. So I want to start with that. Within the public cloud offers, with private, hybrid, and public platforms, Azure enables differentiated experience for SQL Server, basically for two reasons. First, there are specific licensing advantages for SQL Server only available for Azure. So you cannot get those cost savings and licensing benefits on premises or on other cloud vendors. I will talk about them in a bit. And also, there are features only available on Azure. Because the same SQL Server team is delivering SQL on premises and SQL on Azure, all the new investments and all the new features are first available on Azure. Examples are intelligence, performance, and intelligent security. They've been available for Azure SQL for some time, and then they shipped with SQL 19 recently. So those two reasons actually makes Azure one of the best and most economical cloud platform for SQL workloads. On Azure, we have 3 different deployment types for SQL Server. We call them as deployment types of the same Azure SQL umbrella, and they differentiate by the access and control level you get. With managed instance and SQL database, those are the managed platform. So you get access to instance scope, and you can control the instance with managed instance, and you get access to database scope and full control on the database with SQL database. If you need to own the virtual machine running the database engine, and if you are looking for control and access on the virtual machine level, then you should choose VM deployment type of Azure SQL offers. Managed platform, specifically managed instance and Azure SQL database, comes with everything built in. High availability, business continuity, long-term backup retention, automated backups, disaster recovery, and also automated performance tuning and security. All of these features are coming as part of the managed platform. So this is great because in addition to outsourcing the IT and saving a lot of costs by not having the data center management duty on you, managed platform also optimizes the cost to solve the common problems for all mission-critical enterprise workloads. With that, it increases DBA productivity and IT productivity up to 40%, recent Forrester research is showing. So this is the best platform to get maximum return of investment if you are okay with the control on the instance level. There are some reasons you may need control and access at the virtual machine level. And one example is if your application is certified for a specific version of SQL Server, and you cannot just run it on the latest version, or you cannot automate patching because you have to retest and recertify your application for each patch or version, or if you want to or need to run an application side by side with SQL database engine on the same VM, similar to that, reasons that would require connecting to the virtual machine and having control on the virtual machine makes SQL VM deployment type right choice for you. So with other words, you will be balancing control versus manageability instead of leveraging the fully managed platform and limited control. You'll be balancing control and manageability with virtual machine offer. So with other words, again, SQL VM doesn't come with everything built in. It comes with choice of automations. You can use Azure Site Recovery for business continuity. You can replicate the VM and SQL Server onto a different virtual machine on a different region or zone with Azure Site Recovery. You can use Azure Security Center for threat protection vulnerability assessments. You can use Azure Backup Service for a no retention period backup, enterprise-grade backup service. And also you can use our automations for highly available deployments and other automations. So with that, it comes to many services, how many services you need to manage. And this is the reimagined part of SQL VM offer. Couple months ago, actually 6 months ago around, we announced SQL VM Resource Provider. It is a management service running on Azure Data Control Plane clusters, and it is very similar application that we are managing managed instance and SQL database. So the resource provider is actually a management service delivering manageability specifically for the SQL instances running on Azure Virtual Machines. So what does it offer? It delivers automated security patching for SQL Server on and Windows Server within the custom maintenance window you can define. It delivers free automated backup service up to 30 days retention period. You can use it for system databases, user databases. You can enable encryption. You can rely on an automated backup schedule or define your own backup schedule for full and log backup separately. So resource provider offers command line APIs and ARM templates for an always-on availability group deployment for high availability. Either VMs separated on multiple zones or VMs in an availability set to achieve up to 4 nines HA. And also automates best practices for storage configuration. This is a very new feature we announced a couple of weeks ago. If you are using SQL VM Resource Provider and creating a new VM, you can either leverage quick start templates or portal to automate performance best practices to optimize price perf. Also delivers enhanced monitoring and manageability. So once with SQL VM, your VM running a SQL instance is actually integrated into Azure SQL platform. And now it's a visible resource in Azure SQL Service. It can be monitored, managed, filtered together with managed instance and SQL databases. And it offers cost optimizations with flexible licensing. For a SQL instance, to be eligible to run it on Azure Virtual Machines, there are 2 different licensing options. If you already have on-premises licenses and protect them with software assurance, then software assurance gives you 2 rights to transfer them on Azure Virtual Machines. You can either use license mobility benefits or Azure Hybrid Benefit. Azure Hybrid Benefit adds a little bit more to license mobility, so you can use those licenses on Azure Virtual Machines, and this is the AHAB type. Or if you don't have licenses or if you don't want to use them on Azure, then you can use pay-as-you-go licensing model. And in that model, every VM will emit a per-hour meter for the SQL license defined by the addition of SQL Server and the cores available to the VM. And you'll be paying SQL Server license only for the hours the VM was up and running. And if it is stopped and deallocated, you won't be charged for SQL license. So when your application's requirements changes with SQL VM Resource Provider, you can update the license type and addition of SQL Server, which will automatically reflect the billing to optimize cost for you. And finally, the support experience with SQL VM Resource Provider is enhanced because it is integrated with Azure Support Center, and support engineers gets more visibility into your operations so they can deliver a better support. How to leverage SQL VM Resource Provider? So there are 2 options, 2 ways to start with a SQL using a SQL instance on Azure Virtual Machines. You can use the SQL images we publish and update on Azure Marketplace. They are available for all editions of SQL Server from 2008 till 2019. And if you start with a SQL image on Azure Marketplace and provision a VM from a SQL image, that through Azure Portal, it comes with SQL VM RP by default enabled. So all the manageability and benefits are enabled for you. But if you are using a custom VHD, or if you are doing your own installation of SQL Server on any Azure VM, then you need to register with SQL VM resource provider to get access to the free manageability features. Registration starts with registering the subscription. It is not specific to SQL VM RP. Any new resource provider needs to be registered in the subscription scope first and can be done through portal or CLI. And after that, each virtual machine needs to be registered with SQL VM resource provider. This can be done individually on the VM scope, or it can be done in a bulk way. Bulk registration is a very new method. So you can download, import a PowerShell module and give a list of subscriptions. The module will go through all the VMs in the subscriptions and will try to register them with SQL VM RP. And then it will generate a report about which ones are registered, which ones are failed, and why failed. Was it because the VM was not up and running, or there was no SQL instance, or you didn't have permissions? So bulk registration is a recommended and preferred way, because, and also it is unattended. What happens when you register a virtual machine with SQL VM RP is SQL VM resource provider, the backend service running on Azure control planes, pushes a lightweight mode of SQL IIS extension on the VM, and it verifies SQL Server edition and version, and then shuts down itself. So the verification is very lightweight. No SQL Server restart, no VM restart. There's no impact on any resources you already have, and there is no footprint left. It does a basic discovery. It collects the edition and version and creates a new resource, a metadata resource of type Microsoft.SQL virtual machine to represent the SQL instance on Azure data clusters. So without this, you had Microsoft Compute virtual machine resource, which is the generic VM manageability definition. With registration with SQL VM RP, you add one more resource to define manageability for the SQL instance. And these two resources are always linked to each other. They always leave, move, and delete it together. Lightweight registration is the non-disruptive way, and it delivers limited functionality. So it gives you discoverability. You can list all the virtual machines running SQL Server, filter by license type. For example, with the CLI command on the screen, you can easily discover how many SQL licenses you need to maintain because you license them with a hub model. Or you can filter on list based on the version and edition. Also, it enables the enhanced monitoring on the portal and the license flexibility. To get other features for administration, automated backup, HA deployments, and patching, you need to upgrade the mode of SQL VM RP to full. And upgrading to full mode requires a SQL Server restart. And it installs an agent, which is the SQL IIS extension. The agent basically is two Windows services, totally visible through Task Manager. You can see how much CPU and memory those services are using, and you have full control on them, so you can anytime stop or shut down or re-register. So because in VM deployment type, customer owns the VM, we deliver the services through an agent, and you have full control on the agent as well, so you can anytime stop or restart the agent. So I will show what it means actually to register and then how it works. So here is my Azure portal, my dashboard, and I have virtual machine services here. This will give you a list of all virtual machines running any type of applications. It may be SQL Server, SharePoint, whatever. And to find which ones are running SQL Server, you could do tagging or naming, but there is no other method if you are not registering with SQL VM RP. So for example, this custom SQL virtual machine, when I go through virtual machine services, I can see it's a 4-core VM. It is running Windows Server. and I can see all the networking and disk-related information. But I installed SQL Server on it. I know it is running the enterprise SQL Server, but there is no way on the virtual machine's blade to find any information about SQL Server. So this is a perfect example of custom install or self-installed SQL on an Azure Virtual Machine. You get benefits for virtual machine manageability, but you get nothing for SQL Server. So when registered with SQL VM RP, which can be done with this single CLI command, what I say is AZ SQL VM create, name of the existing VM, resource group and location of the existing VM, and the only parameter I need to pass is the license type, either pay-as-you-go or AHAB. So it gives access to, actually it enables another view for the virtual machine, which is SQL Virtual Machine view. So now here in the SQL Virtual Machine service, you will only see the SQL virtual machines, not other ones. So the virtual machines running SQL instances will be listed here. And now you can see the version and edition and the license type of your SQL virtual machines. So this is one example of a SQL virtual machine registered with resource provider in the full mode. So here in the overview, we can see the basic information. And in configure, you can update SQL Server license type. If you didn't register this VM with SQL VM resource provider, you cannot update the license type without any availability impact. Actually, the meters emitted for the VM is hard-coded on the image, and the only way to change them is to recreate the VM. So, but if you register, it's a property of a resource, so you can update it without any availability impact on the virtual machine. Same as edition updates. And also you get storage configuration visibility, like this VM is running F-drive, using F-drive for data, log, and tempdb, and it is a 1 terabyte drive, so you can monitor and extend the drive here. This is a limited manage experience, but in the create experience, it gives you much more options to place data, log, and tempdb, and it automates the best practices for caching and others. So here in the security, you can define the connectivity between public, private, or in your VNet, the port setting, and you can enable Azure Key Vault integration. So you can define a maintenance window for security patching, and for backups, this is the free backup service. You can either choose to have a manual schedule or an automated schedule. So this type of functionalities is currently available. This is on the portal, and there is much more with the CLI commands and ARM quick start templates, and we are building onto the portal. So in a couple months, there will be actually more functionality. So the registration also finished. It's just a couple minutes, and there's no impact on the resource. So it's, I just created another resource for me, which is a lightweight management type of SQL VM RP. In addition to this new management and monitoring experience, also registering with SQL VM RP integrates the resource into Azure SQL family. So here in the Azure SQL Blade, you can monitor and manage SQL virtual machines, which is supported by SQL VM RP, SQL databases, managed instance, and elastic pools. So this is centralized and unified portal to view all of your Azure SQL resources. So this is the first key message, to leverage the free manageability and to maximize actually your investment. We recommend registering with SQL VM RP because it's no impact and it is just benefits for you. So any questions so far? Okay, great. SQL VM Service has a lot of capabilities because all Azure infrastructure is available for you to leverage for SQL VM. I will only talk about a couple of them. To get full details, please download it. There is a lot of information and references, but I will only cover performance, high availability, and scale, and some licensing benefits for the rest of the talk. In terms of performance, there are two things to highlight when we think about SQL Server performance on Azure Virtual Machines. The first thing is, it is SQL Server. It is exactly the same SQL Server you are running on premises. Same software, same bits. So all SQL Server configuration best practices apply. Actually, we tailored them for Azure, and you can It's one of the best, most viewed documents we are maintaining. SQL Virtual Machine Performance Best Practices, recently updated, so you can refer to that. And also, the performance is defined by the resources available to SQL Server. So when you compare SQL Server performance on an Azure Virtual Machine versus on-prem VM or host or on a different cloud VM, we are commonly facing with one problem. So everybody picks the vCores and memory and storage size as a criteria to match the resources available for SQL Server, but forgets the I/O per second and I/O megabyte per second, which is IOPS and throughput limits. So on Azure, VMs are placed on physical hosts, and the physical hosts are shared within tenants. So each VM comes with some soft limits. And these soft limits about I/O per second and throughput operations has a significant impact on SQL Server performance. Actually, when you create an 64-core 400 gigabyte VM, you don't get with the full IOPS and throughput bandwidth. You have hard limits on the IOPS, which is 80,000, and throughput, which is, I think, 1.2 gigabyte per second. So you need to know how much I/O the SQL Server will need to transfer through the network per second, and the size of the I/O you need to transfer per second, and find the right VM that can scale up to those requirements to match the performance. So just matching the vCores, memory, and size of the storage will not give you the apples-to-apples comparison for SQL Server performance. Actually, on Azure Infra, there are some capabilities helping SQL Server performance to optimize price performance a lot, because all hosts, actually memory optimized VM families hosts, came with local attached SSDs, and some capacity of the local attached SSDs are assigned for the VMs. Like again, from E64 example, it comes with 1.6 terabyte local SSD available for the VM to be used as a cache. And if you place SQL Server data and log files, actually only data file, on a premium disk with read-only cache enabled, 1.6 terabyte up to that size, all the reads SQL Server needs will be served from the locally attached physical disk. So it's not going to be a network operation. Considering majority of the SQL workloads today is read heavy and they come with 10:1 read to write ratio, this is a huge performance gain because you'll be paying only for the writes, write IOPS, and so you will be only attaching storage to serve your writes, and all the reads will be served from the local storage, and it's not going to be charging any additional fees for you. The read-only cache, the blob cache, is included in the compute cost, so you're not paying anything extra. Actually, it is a COGS problem for us, but it is a huge benefit for you. Yeah, so you don't need to pay for the whole read IOPS any extra money. All of these, and there is a couple more best practices Azure Infra is actually enabling for SQL Server, is fully documented and also automated with SQL VM RP. Definitely we recommend going through them and making sure your configuration is leveraging them to get the most from your investments. We did, SQL Perf team did a couple tests with SQL Server on Azure Virtual Machines recently, and I will try to explain them because it is a little complicated. Let me know if you can see these numbers. So we did testing with a TPC-E workload. TPC-E is the recommended benchmark for OLTP performance. It is read heavy, and it uses complex transactions, 12 different transactions over a variety of data type. And it is the recommended benchmark to talk about OLTP performance. So we picked an E64 VM, and we attached 2 P30 disks. E64 VM comes with 64 vCores, 432 gigabyte memory, and 2 P30 disks gives you 2 terabyte storage, 10,000 IOPS, and 400 megabyte per second throughput. So for such a target environment, we got another client, and we run TPC-E with Benchgraph and 800 gigabyte database. And what we saw is we run up to 490 transactions per second here. So this required 18,000 I/O per second. And the workload was throttled after 10,000 because P30 disks are only allowed up to 10,000 IOPS. But as you can see, all the 10,000 IOPS are used for the writes, and we got additional 8,000 IOPS for the reads to get this 490 transactions per second. And these 8,000 IOPS are served directly from the local host cache, Azure Blob Cache, and we didn't need to pay for them, but we benefit them. So because this workload was throttled on the write IOPS, we just add more storage. We add 2 more P30 disks, which made 4 terabyte capacity up to 20,000 IOPS and 800 megabyte per second throughput. And then with this configuration, we went up to 800 transactions per second with TPC-E. So this transaction per second is measured on the client side, not application transactions, not on the SQL Server side. So it includes all the reads and writes, everything. And we, of course, we had to increase the number of users to increase the load to drive it more. So with this new configuration now, the workload drive up to 36,000 per second, and only 20,000 of them was served from the P30, and all of them were used just for writes. So only the writes were coming from the remote storage, and we were paying for them. All the reads, which is actually here, another 17,000 is served from the local cache for free, and this is how the workload could scale. And if you can see here, the CPU is only 45%. So we're not leveraging the full capacity of the VM, even though we attached 4 terabyte storage, a lot of IOPS, and our database is just 800 gigabyte. So this is a very critical point. You cannot match for the size if you are considering performance. You need to match for the IOPS throughput. And size and IOPS throughput limits comes together. So to get 20,000 IOPS, you actually need to pay for 4 terabyte, or you can mix and match in different configurations. But we find P30 SKU is very efficient for, cost efficient for SQL Server workloads. So we tested with the high performance storage, which is UltraDisk, to prove the impact. Instead of P30 disks, now we provision one single UltraDisk up to 80,000 IOPS. It comes with 2 gigabyte per second for max. And when we run the same workload on the UltraDisk, now we saw up to 1,500 transactions per second. So this is 3 times of 2 P30s. And this resulted with 60,000 IOPS, again, 30 reads and 30 writes. So with UltraDisks, we could achieve, if you notice here, the CPU is 90%, so it's 94, 92%. So we could get the maximum performance because latencies are super low, it's microsecond level. But you are paying for the whole IOPS, so there is no cache involved in UltraDisk because all the reads and writes are already microsecond, and all the IOPS are paid. So it's not a way to optimize cost, but it is a way to maximize performance if you really need it. So after, similar to our internal tests, GigaOM, a third-party vendor, a trusted vendor, did similar testing on Azure and EC2, and they compared SQL performance on different VMs. So on Azure, they choose the same SKU, is64 and premium disks. And on EC2, they choose R4 16x large with general purpose storage. They match the size. And they use TPC-E, a scaled-down TPC-E model. The result was on Azure, they could go up to 1,000 transactions per second. And on AWS, they could go up to 320 transactions per second. And the reason of it was the free IOPS, the local cache is enabling for SQL. And TPC-E is a read-heavy workload, which most of the workloads are. In addition to Azure Hybrid benefit savings, it came to 87% less for a transaction cost for the whole 3 year when it is hosted on Azure VM versus similar matching EC2 VM. So this is a story they are going to publish in a couple of weeks. So you can just get all the details and redo the test and do the comparison by yourselves. And they did the testing with Linux, and the numbers were very similar. The performance is a little different on Linux, but the price performance advantage is again up to 67% when we think about the cost of per transaction for a 3-year price model. So the key point here is please be aware of how to compare and what to expect from performance and how to configure your environment to maximize your benefits. You can configure storage and VMs for the maximum performance or for the price performance advantages according to your requirements. And all of this information is now public and accessible for you, and some of it is already automated. Any questions so far? Mm-hmm.
How does the licensing model look like when I have to run SQL on Azure VMs? Licensing of SQL Server?
Yeah, there are 2 options. You can either use your existing on-prem licenses, and with software assurance you can transfer them to Azure, or you can use pay-as-you-go licensing model. And with that, you don't need to pay bulk for the licenses. You will be paying SQL license as part of monthly Azure bill based on the usage. So for the hours the VM was up and running.
Can I still have non-licensed secondaries in Azure?
Can you say again?
I need a license for secondary, running secondary SQL jobs.
Yeah, I will come to that just in a minute. So the next topic is high availability. A single virtual machine offers high availability SLA of 3 nines, and you can increase it up to 99 and 95 with having 2 VMs and availability set, or 2 different availability zones up to 4 nines. So if the VMs are distributed into multiple availability zones, then the SLA will be 4 nines. But the SLA is on the VM level, not on the SQL level. So to bring the SLA to SQL, you need to use SQL Server HADR techniques, and all of them are supported on Azure Virtual Machines. We published a recent case study, HNR blog, running a text application. They are using SQL 2017 on Azure Virtual Machines. So they are leveraging scalability benefits because it's a seasonal workload, but they are very mission critical and they have to be highly available all the time. So they are using zones and one synchronous replica on an Azure region and an asynchronous replica on their on-premises center with availability groups. So it's a very useful and very, it's a great case study if you want to learn more. With that, the recommended high availability solution for SQL Server on virtual machines is availability groups. This is a reference architecture, and the link below gives you all the scripts to deploy this for an N-tier application running on virtual machines. So for data tier redundancy, we recommend a Windows failover cluster spinning over multiple regions, and you can connect it to your Active Directory, either hosted on a VM on Azure data centers or extended. So a synchronous availability group replica on the same availability set or availability zone, I mean different availability zone in the same region, and an asynchronous availability replica on the paired region or a different region is the recommended and widely used method to achieve HA for modern SQL workloads. And to deploy this, there are 2 automated options. You can do it manually, totally. It takes 3 to 4 hours. It's error prone. You need to configure load balancer and understand Azure networking a little bit. If you don't want to do that, there are 2 ways to automate. You can use Azure CLI commands, which is AZ SQL VM group create, AZ SQL listener create. Very simple commands to simplify this process, or you can use the ARM quick start templates, which deploys the whole solution for you. If you have workloads that are running many databases per instance, or if you simply require instance level high availability, not database level high availability, then you can use failover cluster instances. And with premium file shares now, we have a managed and trustable shared storage solution for SQL failover cluster instance on Azure Virtual Machines. We recently certified this solution, and it has actually significant benefits in terms of maintenance and management. Also, it comes with burstable performance. So you do not need to provision the PFS share for your peak IOPS. You can provision it for your baseline IOPS, and it will give you up to 3 times burst credit for the times you are not using the share. And also, PFS is can be synchronously zonal redundant, so you can use it for SQL data and log files, together with different VMs on different availability zones. So SQL Failover cluster instance with premium file shares is a recommended option if you are looking for instance level high availability for the simplified administration and management. Also, shared storage spaces direct is offering a shared storage solution. So you can also use shared storage spaces direct. Storage spaces direct will be a cheaper solution for the high IOPS requirements. If your workload is really performance dependent, it requires 50,000, 100,000 IOPS, then S2D will be a cheaper option for you. I mean, if the workload requires IOPS all the time, not just peak or seasonals. For backups, Azure Backup Service has been supporting SQL Server on Azure Virtual Machines for a couple of years, and recently they announced additional support. So now they support SQL Server 2008 and SQL 19 on Windows 19. So all versions of SQL Server are now supported with Azure Backup Service. So this service is an enterprise-grade service, so you can have a portal for the point-in-time restore. You don't need to manage storage for the backup files, so it's a great service, actually. Now, also, they offer restore as a file, so they give you the backup files. You can go and restore anywhere else. You don't need to have an Azure VM to have a restored SQL instance. For scalability, Azure Infra offers with MV2 series, this is also a recent series, up to 416 vCore and 11 terabyte memory virtual machine sizes are available. And the biggest one comes with 14 terabyte locally visible storage for the VM, so it can be used for TempDB. And it comes with a lot of cache, so you can find all the cache sizes in the documents. From storage perspective, each ultra disk, a single disk, can scale up to 160,000 IOPS, but there's no VM that can scale up to that, so it's going to be hard to use it, the maximums. But it can scale up to 64 terabyte and 2 gigabyte per second. So from the scale-up perspective, you have a lot of way to go on Azure Virtual Machines. But what is commonly used is memory optimized VM sizes with E series, D series, and M series are very heavily used for SQL workloads. And now we announced EAS and DAS AMD-based version of this memory optimized series. They come with CPU sizes between 2 cores to 64 cores, and the vCore to memory ratio is quite high, and they come with a lot of high throughput and IOPS capacity as well. So we did a lot of testing with those, and it is very cost optimized, and it's offering price perf benefits for SQL workloads. You can find all the details in our docs about this. I have to highlight the constrained vCPU size VMs, because as I said, SQL is IO intensive, and if your workload requires a lot of high throughput and high IOPS, you may need to start with a VM that actually is coming with vCPUs that you do not need. For example, to get 1.2 gigabyte throughput, you may need to go a 32 core VM or a 64 core VM, but you may only need actually 16 cores. So for these scenarios, you can start with a high-end compute and constrain the vCPU on the compute up to half or 1/4 of the VM. So you can have an M128 core machine with all the memory and capacities available for you, and you can constrain it up to 32 cores. So this is a huge benefit for SQL license savings, and of course for SQL performance. Finally, for license flexibility, there is a new software assurance benefit a couple days ago launched. So right now, you don't need to license the passive HA replica on Azure VMs, it's the same as on premises. So if you have a passive high availability configuration like failover cluster instance, you don't need to license the passive. Or if you are having an always-on edge synchronous replica that you are not using for read-only purposes, you don't need to license it. With the new SA rights, now there is a free DR benefit for Azure available. In addition to the free passive replica, now you don't need to license the free DR replica. The on-premises, the primary can be hosted on Azure VM or on-premises VM. DR on Azure is free with the recent SA benefits. And it is only free on Azure, so not on different cloud providers. So additional licensing benefits, dedicated hosts actually offering up to 50% license savings for SQL workloads, because you can license the physical cores of the host with the dedicated host model, and the maximum you can license is 32 cores today, but it comes with 2-to-1 virtualization, because this is what SA offers you. So you license 32 physical cores, but you get capacity up to 64 cores, and you can put any VM size. You can mix and match the VM sizes on the host. So this gives you, instead of using a multi-tenant E64 machine, you can get a dedicated host and just pay for the 32 cores, but you still get 64 vCores. It's exactly the same performance. There will not be any perf or any other differences, because dedicated hosts are actually making the current compute physical host available to you. For SQL Server 2008 and 2008 R2, hopefully many of you already know, they came to end of life, so there won't be any regular security updates for them. And to be compliant, you need to actually sign an ES3 contract if you are on premises to get further security updates for the end of support versions. This is called ESU, Extended Security Updates Contract. And if the VM is migrated to Azure, you don't need to sign anything, you don't need to pay anything. All the ESU security patches are delivered for free for Azure VMs. If the SQL is running on Azure, the patches will be free. So you get 3 more years to modernize and upgrade those workloads by migrating to Azure. And also the automated security patching and automated backup and similar services are free. And the license management capability is also differentiator services for SQL VM. So the last key point here is be aware of the licensing benefits available and specific to Azure, and please leverage them if you are not leveraging already. So this is, there is 2 minutes left, and this is all my content. If you have any questions, please let me know. Okay, great. Thank you.